The sound is about 5 minutes of that presentation. So you have to guess. You can see the slides, but then the sound comes in for the rest of the
So
presentation.
we should
So-
all learn how to read lips, right?
The library website, you mean the Santa Cruz County Library website? or
Right,
so?
this, the
They're all
Santa
big
Cruz.
Yeah.
It's santacruzpl.org.
Right, thank you.
And then if you scroll all the way down to the bottom, there's the YouTube icon. It looks like a little triangle. And you click on that, it'll take you directly to the YouTube, the library's YouTube page. And there's a playlist with John's
Thank you.
presentations.
Featured comment. Stars.
So that's where you can go to get more of obviously what was in the first presentation, but I'm going to recap it a little bit. So here we go. This is kind of a table of contents of what was presented in January. And it's about the atmosphere, about the greenhouse effect, how the weather has changed because of warming, especially at the poles, storm patterns, temperature, storms and droughts, wildfire, and ocean acidification. And I'll touch briefly on a few of these to get us back to speed. So this is a plot of global temperature from about the time of Christ through the present day. And there was a little ice age in the Middle Ages. You can think of all those movies where it's really cold in England, snow on all the castles. That was a real thing. And what I'm going to focus on the next slide is that area that has the red line at the bottom, which is the last 100 years or so. And that's what this looks like from about 1850 to the present. And the graph is the difference from average in degrees centigrade. You can see it was cooler and then it gets warmer. And the gray line is the amount of carbon dioxide in the atmosphere. And we started about 1850 because that's when the Industrial Revolution really gets going and there's a lot of carbon dioxide starting to go into the atmosphere. So obviously the temperature, the global temperature tracks well with the amount of carbon dioxide in the atmosphere. So why did carbon dioxide go up? These two lines, the blue line is the atmospheric carbon dioxide as in the previous graph, and the gray line are the carbon dioxide emissions from human activities. And you can see those track very well too. This is a very summary picture of it. There's an awful lot of evidence that these CO2 concentrations in the atmosphere are indeed because of human activities. Why is CO2 in the atmosphere making the planet warmer? This is the greenhouse effect. What happens is when CO2 gets in the atmosphere, it's transparent to visible light. Visible light goes right through it, but it's opaque to the wavelengths of heat. And so visible light that bounces off the Earth's surface, like it bounces off the moon, will be radiated back into space. But the warmth, the heat waves, the energy in the heat wavelengths gets trapped and reflected back to the Earth. So it really is just like a greenhouse where the light comes in through the glass and the heat can't get out, so it gets warmer. And this diagram distorts the thickness of the atmosphere. The atmosphere that we're talking about here, where the carbon dioxide is getting trapped, is about 11 miles thick. And if you walk down to the bluff and look down to the power plant at Moss Landing, that's about 11 miles away. So that's how thick the atmosphere is. So it's a very thin shell over the whole Earth. And you can see why it would, in fact, get filled up with carbon dioxide when a lot is emitted into it. So as the planet warms, ice melts. And this is particularly a problem in Antarctica and Greenland because that ice is sitting on land. It's not floating in the ocean. It's sitting on land. So as it melts, it runs off the land into the ocean, raising the sea level. And this is from a tide chart, a tide meter, a gauge by the Golden Gate Bridge and a couple of other places over the last century. Sea level has risen by 8 inches in San Francisco and La Jolla since about 1900. And it's interesting because the orange line is from Crescent City, and it doesn't show any increase because Crescent City geologically is actually, the land is rising at about the same rate that the sea level is rising. But we have experienced 8 inches of sea level rise over the last 120 years.
Rising from subduction?
Yeah, basically, yeah. The oceanic plate is going underneath the granitic continental plate, lifting it up, which happens all along our coast, but apparently it's more active there. So this was December this year, and as sea level rises, it's kind of like adding more onto a high tide. This is really a combination of a December high tide, which they often call king tides because they're so high. I think it's probably 6.8 feet, plus a storm. So this is really more storm surge than sea level rise. But as the sea level continues to rise, this will be exacerbated. Also, storm intensity is becoming greater because the ocean is becoming warmer. And as I explained in the last presentation, as you can see in the recording, warmer temperature oceans or land tend to heat up the air, forcing it up, causing stronger storms. Drought, obviously, also an issue. We've forgotten about it, 2 years of rain, but after 10 or 12 years of drought, a lot of the Sierra foothills look like this. This is near Shaver Lake in 2018, and this is near Shaver Lake in 2020. This is the Creek Fire. Intense wildfires fueled by dry fuel and dead trees. So I'm going to go over a couple of adaptation projects. Again, this is what we're trying to do to buffer ourselves from the effects we know are coming. And this was the topic of the last presentation, but I'll go over a couple quickly. This is a prescribed burn in Mount Madonna. There's a really active prescribed burn association that also involves a lot of local tribes who traditionally did prescribed burns to enhance the food resources and cultural resources that were used for generations. And a number of the tribes are actually very good at this and are involved with these processes. But prescribed burns take out the fuels. They make it less likely that fires will become catastrophic crown fires. There's a lot to it, but a lot of it's getting done these days. So that's one type of adaptation. Another is using wetland restoration to create spaces where floodwaters can go so that they won't end up downtown. And this is an image of a few projects around the Pajaro River that are being done. The project areas are within the black lines, and they're estuarine and wetland and riparian riverside restoration to create what they call accommodation space for waters to go. And healthy wetlands buffer the impacts of floods much better than a lake or an empty space. So these are projects being done by the Land Trust of Santa Cruz County, and then up in the upper right is a triangle that's actually about 60 acres. It's a project being done by the Pajaro Regional Flood Management Agency at the confluence of Salsapuedes Creek and the Pajaro River to restore what is now unused farmland because it's too soggy to farm, and make it a wetland restoration area where floodwaters can go to. And it's right next to the Bridge Street neighborhood in Watsonville, which is low-lying, low-income area that has been flooded often in the past. And this is a similar situation in downtown Santa Cruz. The project down by the boardwalk there, outlined in black, is at the mouth of the San Lorenzo River. That's actually a dune restoration project, trying to build up the dunes so that those storm surges don't go into the beach flats. And then up the river a ways, there are a couple of floodplain restoration projects to, again, give the river some accommodation space so it won't flood the neighborhoods downstream. And this is a whole series of projects like these, wildfire projects, flood risk reduction projects that are under consideration for funding right now. There's a large NOAA program and a proposal that we've put in for this region to fund all these projects. It's a huge opportunity to give us a little breathing space from some of these climate impacts. So the one impact that I discussed last time that I wanted to mention again here is ocean acidification, because it's rarely talked about. Most people think about the planet's getting warmer, heat spells, droughts, floods. But this is a big one because the acidity of the ocean has increased 30% since the Industrial Revolution because of the CO2 that's gone into the atmosphere. CO2 is very soluble, it goes into the ocean, and it drives the chemical reaction towards bicarbonate ions and free protons, hydrogen ions, which make it more acidic. So there's not a lot you can do in terms of wetland restoration and stuff to stop something like this. There are some things we can do, and I'll mention a couple later. But it really drives home the idea that we need to adapt, but we also need to slow down climate change by reducing the amount of carbon we're putting into the atmosphere. So that's what I want to talk about for the rest of the presentation. So people talk about climate change adaptation and climate change mitigation. And mitigation is basically just trying to prevent greater damage by reducing primarily carbon dioxide, methane, and a few other gases that trap heat in the atmosphere. And I want to talk about a few different categories. Climate engineering, which is fascinating, but a lot of work. Reducing carbon pollution, which is less glamorous, but a whole lot cheaper. Things that we can do and where we're heading in the future. So I'll start with climate engineering. And this is a cool little graphic of a lot of the types of things people are thinking about. The airplane there, I'm not going to get into the space mirrors. All of these things sound crazy, but some of them might work. The plane there is spreading some sort of reflective aerosols. There are a number of things. Diamond dust is under consideration because it's very reflective and it's inert, so it shouldn't hurt anything. But probably the most likely is calcium carbonate. I'll get into that a bit more. Cloud seeding I won't talk about, but the idea is clouds are white, they reflect light back into space. So if there's more clouds, there's more reflection. I really don't know how that adds up in terms of weather in the atmosphere. I'll talk about biochar and afforestation, which means planting trees and growing forests. And over here on the bottom left, iron fertilization of the ocean. I'll talk about it in a minute, along with alkalinity, trying to make the ocean more alkaline. And then way over on the right, CO2 capture. So here we go. So spreading reflective particles. We're talking about covering the entire globe with reflective particles. And obviously that's going to take a lot of plane flights. And you're talking about plane flights that themselves are emitting a lot of carbon. So it's a little bit of a moving target. But people are looking at it because it might come down to this. If we can't cut our emissions. But it's obviously expensive. The lowest number I saw was $4 billion a year. And I think that's a huge underestimate, and it would certainly increase. And it has to be continuous, because if you don't address carbon, as soon as you stop putting the particles in the air, the temperature is going to go right back up because the carbon's there capturing the heat from the sun.
Does it have to be approved by whatever territory?
That's an excellent question. That's a fantastic question. And they're trying to actually work that out right now. And no, right now it doesn't. Anybody, pick a country, they could start a climate seeding project, and there is no law about that yet. So that's a huge question.
How much does it spread out of the region where it's
I don't know. I think like
jet stream goes around?
Yeah. So I think they stay up for about a year.
Really?
I think it's on that order because they're really fine particles and they put them up pretty high.
above any precipitation.
Yeah, kind of at the top of the atmosphere. Yeah.
Can a passenger plane, normal commercial passenger plane distribute those items?
Yeah, I think so. I mean, I think that's the idea. I think, like maybe, Air Force transport type planes or, even commercial passenger planes, sure. You just put sprayers out there on the wings or something. But one of the most interesting things about that is if we did this, the sky would no longer be blue,
Oh.
Under a white sky.
it'd be white. So there's an excellent book, actually, you mentioned it.
Yeah.
Under a White Sky. This was the book of the year last year at UC Santa Cruz. They have a book that everybody reads so they can all have something to talk about. And this was the book. And I read it. It's a fantastic book. It's about human attempts to remedy problems that were caused by humans trying to solve previous problems.
Yeah.
So it's really fascinating. I definitely recommend it. And the author is very clever, presents this stuff in a really entertaining, interesting way. Okay, to the ocean, iron seeding of the ocean. And I have a special interest in this because I was a grad student at the Moss Landing Marine Labs when John Martin was the director. And it was a small marine lab. We all got to know each other pretty well. And he had this famous quote, "Give me a half tanker of iron and I will give you an ice age." And it's a bit of hyperbole there, and he knew it. But he wanted to kind of get some attention to not only this process, but the fact that we're doing a completely uncontrolled experiment with the atmosphere with CO2 additions. We might as well try and do controlled experiments to stop it. So the way it works is, well, background on this. Before John Martin and George Nauer at the Moss Landing Marine Laboratory started to do more careful experiments and measurements, everyone thought that the concentrations of trace metals in the ocean were pretty high. But it turns out the reason they thought those concentrations were high was because their equipment was contaminated with trace metals. So their samples had more metals than the ocean did that they took them from. But this went on for decades. And they came in, John Martin and George Nauer came in with clean techniques, and they would have filtered air coming into pressurized laboratories so that any air that moved always went out of the lab, all clean techniques, which are the state of the art now, which are the commonplace now. But one of the things they realized was that the ocean is deprived of iron, and it's probably the limiting nutrient in phytoplankton growth in a lot of places. So if you add iron to the ocean, phytoplankton will grow.
Deprived artificially or just?
Well, basically, it's just raw iron that is dissolved, and so it's in a liquid tanks.
There's.
And
something-
it's
what's this?
I think it's just Fe2 or whatever it is, just basic iron ground up.
Oh,
But I'm not sure. I should know that, but I don't. But so you put the iron in the ocean, and the phytoplankton will grow, and since they're plants, they will take in CO2 and give back oxygen, and make less CO2 in the atmosphere. And then the dead plankton sink to the bottom of the ocean where they sit for very long periods of time, hundreds of years. So the problem with it, though, it works. This is a satellite photo of a Woods Hole experiment off South America, showing phytoplankton blooms after the boat went by and put iron in the water. But the problem are these little guys, the zooplankton. This is a copepod, which is very common, and they're set up with their little antennae to eat lots of phytoplankton. And so it's kind of like you put nutrients out in the pasture, the grass grows, everything's good, and then the cows come along and they eat it, and then they're putting CO2 back. So it's not over, but it's not as clean a solution as it might have been hoped.
So the zooplankton are they releasing CO2?
Yeah, they're
again,
respiring. They're animals, so they're taking in
tablets?
oxygen and giving out CO2, just like we do. So it just turns it back around. So this is a little newer. This is ocean alkalinity enhancement. The idea is to mine silicates or carbonates. There are a lot of common rocks that are alkaline. And this is what happens in nature through erosion. Rocks wear down through the rain and everything. The rivers take it to the sea, but it happens over thousands to tens of thousands of years. And the idea is to speed this process up by mining it, taking it out on boats, or putting it along a seashore as sand or whatever, so that when the ocean comes up, it'll dissolve and go into the ocean. And what it does is it kind of pushes that ocean acidification equation a little further to where it binds up those carbonate ions, and then they sink to the bottom. Once again, and you can also produce alkaline particles by extracting it from seawater, like that little factory in the middle. All these things are obviously carbon intensive to drive the bulldozers and the trucks and
Yeah,
everything.
does that affect bottom feeding fish?
Well, that's a really good question. People don't really know how that's going to affect what lives in the ocean. There's a group down at UC Santa Barbara right now that's doing experiments on alkaline adjustments and phytoplankton. And so far it looks good. So far the phytoplankton seem to tolerate it pretty well, but I think they're only working with 2 kinds of phytoplankton. And, there's a lot of things out in the ocean that can get. So these things are iffy,
Are they working off Channel Island in that section?
well, they're just doing it in the lab.
Oh, okay.
Yeah.
What about here? Are they doing it out in the?
Well, there's all kinds of, no, I don't know of any alkalinity experiments that are actually happening in the open ocean.
Oh,
I think a lot of this is just preparing for it by trying to, think about what the problems would be and trying to figure out how bad they might be. So, carbon capture is popular, especially by people who produce carbon and are regulated, like power plants. And this is an image from the BBC of a power station on the shore of Britain or somewhere on the North Sea that's extracting natural gas from the ground. They burn the natural gas to generate energy, and then they have scrubbers in the smokestacks that capture the carbon, and they pump that back down into the ground. So I'm not an engineer, and I haven't looked at what's involved here, but people are taking this very seriously. And here's an image of a plant in Iceland that is functioning, and it's taking CO2 right out of the air and putting it down in the ground. And it does about, 4,000 tons of CO2 per year, which is the equivalent of about 10 million car miles. So
it's just taking it
just
there
right-
on site.
the one side just taking it out of the air.
Little
Yeah.
grain.
Yeah, it's just like a filter you might have in your house,
Right?
to
It's-
take dust
It
out.
doesn't have to be near the cars. It's just pulling it out of the.
Yeah, I mean, the atmosphere is pretty well mixed, so.
Okay.
Mhm.
Aside like that, is there it would be anecdotal, because I imagine that it's not set up to scientifically measure this, but have the people talked about the animals being a little bit different, or the health of the people being better right around somewhere like that, or any of these options? Because it would just be interesting to see if the local atmosphere area was a
Yeah,
little
that's
bit
interesting.
better.
Yeah, interesting. I don't think so. I think, I mean, I don't know. Something like this, I would think, would be about as benign as anything I've shown so far as not changing anything that would affect organisms. But yeah, the local effect is interesting,
And it's injecting the CO2.
down into the ground.
So if they
Yeah.
injecting it CO2 as gas?
I think, I think so. Yeah, I'm not sure. They might fix it as attached to something and put it down. I'm not sure. Tom, and then yeah. Sorry. Thanks, Tom.
On supplements or reduction of CO2 that they take a lot, so shouldn't we be hoping about modifying the doesn't burn? Because if they stop, because eventually there's going to be a cap on the CO2. Again, if we don't modify those first, to at least we keep taking in that same current rate, once they stop taking it naturally and have to supplement it, wouldn't that ideally be a lot worse than not modifying them?
Yeah, it does. So I think your question is about overshoot. Like if we're trying to limit carbon dioxide, but we overshoot and we take too much carbon dioxide out of the system. Yeah, so that's definitely a concern, but I don't think anybody's close to thinking that we're going to overshoot. There's so much CO2 out there to be dealt with that if we got even close to getting back to pre-industrial concentrations, I think people will be amazed. But that's a really good question.
Yeah, they were sort of that.
Yeah, that's a really good question.
Potentially problematic. Depends on how it's made.
Yeah, like if it leaks back out.
Imagine sci-fi story of the.
Yeah.
Well, we get in the aquifers.
Yeah, I mean, CO2 is really soluble, so it might be that they're bubbling it into a liquid and putting it down. I don't know the answer. It's a good question, though. If someone does.
Have there been positive effects, and if so, over what region, you know, like how far do they extend?
You mean,
This is being done now,
yeah.
and have they seen a difference in weather?
Well, like I say, the atmosphere is really well mixed. So what this is really going to do, it's not likely to produce a local response. It's not like the CO2 is going to be lower around this and then get higher further away because it just gets mixed so much. It's an interesting question. And then one more, let me go you first.
Very interesting, because it is relevant to this huge question of scalability.
Sure.
And his slide doesn't say anything about the cost of it. You know, the cost of these projects is really variable because a lot of it's experimental, and the question is, how do they get the power? What's the cost and power and all that stuff?
Yeah.
But it's not cheap, and to scale it to the extent that would make a difference is kind of frightening from what I've read. Not that we won't need to do it.
Right. Absolutely. And I'll say now what I think I was planning to say a couple more slides in that about 8 years ago, I went to a seminar series up at UC Santa Cruz, and it was about climate engineering. And these engineers, top notch from all over the country, came and they presented their ideas, and every single one of them at the end of their talk said, you know, it's a lot easier and cheaper to just quit burning the carbon.
Right on.
You know, and every single one of them and these were their pet projects. These are the things they were really into.
They spent a
So
lot of money doing this.
yes, but the expense and yeah, the scalability, it's the whole planet we're talking about. So, you know, that's about as big as we can scale right now. So,
I think that's the bottom line.
yeah. Let me do one more question, then we'll keep going.
Traffic, so it's not like it's taking the carbon, it's actually into the surrounding geological population spreading out throughout the underground. You don't really have to worry about blowing up.
I think you're absolutely right. Yeah. Okay. Okay, so I wanted to just come up with a convenient unit for us to talk about. The last slide, I think I said that they were doing about 10,000 car miles a year, or 10 million, what was it? 10 million cars off the road, I think. 10 million car miles. So that's a convenient unit. And basically, if you drive the average US car 25 miles, it kicks out 10 kilograms of carbon, which is basically a pound a mile. So we can think of a pound of CO2 being emitted into the atmosphere every mile that an average US car drives. So I'll come back to that unit as we go along. So forestation has been a promising approach to getting carbon out of the atmosphere for a long time. One of the tricks of forestation that has been learned over the last couple of decades is that you have to manage those forests. You can't just plant the trees in the ground. But the other thing is the counter to that is deforestation. And this is a photograph at night of the Amazon. It's a NASA satellite photo from 2019. And those are all fires. And the forest is still being cleared for agriculture and other uses. And so we do want to plant trees, but we really need to stop the loss of forests as well. And there's a policy side to this that I wanted to highlight, which is public policy matters. And public policy is often associated with the people who are in office, of course. And this shows the number of, let's see, it's kind of a backwards. Yeah, so it's basically, it's the amount of trees lost on the y-axis here. So when President Lula was president of Brazil, thank you. I was a geography major. When President of Brazil, a lot less trees were lost. The number of trees lost every year went down and down and down.
Oh, okay.
So that's the thing, is the number of trees lost declined while Lula was in office. And when it was kind of hung there, and then Bolsonaro came into office, he had a different set of policies for the Amazon, and deforestation started increasing again. So we'll come back to public policy in a bit, but it does matter. This is not all just engineering. But back to engineering, there's some ideas about burying carbon, like burying logs. And here are a couple of approaches. You can see the third one over there, burying wood, is 3.7 tons of CO2 equivalent. And I'm not going to try and do that in my head what that is in car miles, but it's like 100 times less than restoring a wetland over here on the left, or biochar, which is happening a lot around the Monterey Bay area. When they clear eucalyptus trees, they basically burn them in a kind of a sealed container. It's like making charcoal, and then you can either bury it or you can use it to extract pollutants from water in what they call bioreactors. It's just like carbon filtration. But burying biochar and restoring wetlands are two ways to use natural processes or to use plant material to lower CO2. Burying wood's not that great, and even planting trees is only about 100 times less effective than these other two on the left. And this slide is much too complicated, but I wanted to focus on the wetland restoration. The coastal wetlands that are circled in red and the restored coastal marshes, they each sequester, they pull carbon dioxide out of the atmosphere at a rate of about 1,000 pounds plus per acre per year. And so that's basically, 900 to 1,800 car miles per acre per year. And these are, I think, some of the most promising ways to deal with it, because in California, at least, about 90+% of our historic wetlands have been paved, basically, or converted to some other use. And so restoring them is good for the environment as well as good for CO2. And that takes me back to this slide that I showed before, in that not only are these wetland restoration projects helping to protect farmland and cities, they're also sequestering CO2 and taking it out of the atmosphere. So I think as far as things we can do other than reducing our emissions, wetland restoration is a good one. Okay, so a little bit about what each of us can do, and obviously reduce our carbon pollution. The second one, we have this fantastic thing that here, which is Central Coast Community Energy, and I'll talk about it in a minute, but it's a fantastic change in the way our electricity is sourced here. And 3CE now covers 6 counties from Santa Cruz down to Santa Barbara, I believe. I'll talk more about that in a minute. And then, of course, supporting good public policy. So, 15 or 20 years ago, this entire presentation would be about this stuff, changing your incandescent light bulbs into LEDs. A lot of these smart switch type things you can read about on the 3CE website. There's some really cool things where, I've had it explained to me a number of times, but you plug them into your outlet, and you plug your freezer into that. And if there's some sort of a brownout coming, it'll cut the power use, all these smart tools. But all this stuff, so I'm not going to spend much time on it. But I did want to focus on my favorite solar appliance, which is the clothesline. So This is our clothesline. In foggy La Selva Beach, you know that in the summertime, and a lot of times it is foggy and wet, and the clothesline still works.
Yes.
So I'm gonna do some calculations here. We do about a load and a half of laundry each week. Only about 10 of those go into the dryer. So that means 68 of them go on a clothesline. Dryer load takes about 3 kilowatt hours to run. That means that annually we've saved 204 kilowatt hours by hanging clothes on a line. The average amount of CO2 that is used when making electricity with power plants in the US is about 175 pounds of CO2 per kilowatt hour. Now, that means we've, let's see, I guess you don't have it for our particular house, but this is something on the order of 3,400 pounds that we save every year of CO2 by using a clothesline. Now, the kicker is when you say there's 82 million single-family homes in the United States, you toss a number like 84 million into the mix, and you come up with these humongous numbers of CO2 that could be saved. 14 trillion pounds a year. 12 trillion car miles per year. That's 4 times as much as we actually drive in the United States. We're talking about a clothesline. So and then there's the personal money savings too. But the kicker here is you need that 82 million. And this is one of my favorite songs from the 70s. We need everybody to chip in. And it's so easy for people to say, oh, it's not going to matter if I change my light bulb. It's not going to matter this and this. But if everybody had a clothesline, we'd be worried about overshoot, like he was saying, not enough CO2 in the atmosphere. So this is just one example of how it really takes everybody to kick in. And if everybody does, we can do amazing things. So I talked about 3CE. They tried to start out by doing 100% clean energy right off the bat. And there are a lot of economic issues that run into that, especially with peak power demand. And they had, and also with California Public Utilities Commission. The Public Utilities Commission has not been kind to community choice aggregation organizations like 3CE. It's this balance between 3CE sources it by having contracts with large solar farms and geothermal power and that sort of thing. But it gets delivered through PG&E. And so PG&E has this leverage point where they're always trying to push back against the community power agencies to put them out of business if they could, or just otherwise pressure them. And the Public Utilities Commission needs to hear from you. Governor Newsom needs to hear from you because they have been not supportive of rooftop solar lately, and they have not been very supportive of these community choice power sources.
What does Governor Newsom support?
Well, Governor Newsom appoints the members of the California Public Utilities Commission, and there's a very close relationship between many of those members and the publicly owned utilities like PG&E. So I honestly do not follow it close enough, but people I know who are very good at this and do follow it are tearing their hair out all the time with the Public Utility Commission decisions. So, okay, so this is what it looks like on your statement. Pretty much everybody's statement probably has this on your PG&E bill, because you have to opt out if you want to go back to PG&E as your source of power. That was a nice thing that everybody got transferred over to 3CE, and then you can opt out if you want to. But you can see that we actually have solar panels. So our electricity is $2.97 for this month, a couple of months ago. I guess it was December. But the delivery charges from PG&E are twice as much. And then our gas charges $70 a month. And we're really trying to convert from gas to electricity. We have a gas stove, which is really nice. We have gas furnace, which is really hard to switch out because our house has has been remodeled a number of times, and the ducting is tricky and all that sort of stuff. But we need to get the gas out. So, and just the last thing is that they get their electricity from clean sources. It's a community-owned, not-for-profit with a community advisory council that's very active. And the revenue stays local. They have grant programs, all kinds of programs to put money back into the community. And they include a lot of incentives to electrify your car, your house, et cetera. If you go to their website, it's pretty amazing what you can get support for.
Does PG&E have the grid tie agreements now? So when your solar goes in, your meter goes backwards?
That's another public utility issue. Starting last year, they dropped what you'd get paid for the energy you generate down to about 15% of what it was before. So
But they still-
running the meter backwards is not nearly it. I mean, you get about 15 cents on the dollar for what you give back compared to what you buy from them.
Oh,
It used to be 85 cents on the dollar until last April. And that was the Public Utilities Commission. And to be fair to the Public Utilities Commission, I think what they were trying to do is they were trying to balance out there's a lot of solar going into California, and it's creating surpluses in the daytime that are not compensated for at night. And the Public Utilities Commission wanted to incentivize people getting batteries with their solar systems. And so we did get batteries, and it's great. The power goes out, all our neighbors' houses go dark, and our TV doesn't even blink.
Is it
So,
Tesla system?
oh, no, it's end phase.
In
End phase, yeah. It's been really good. So shout out to 3CE. Okay, here's a new one that you might not have thought about, but if you've got a lot of data, if you've got a lot of photographs, back them up on your personal hard drive. Don't store them on the cloud, because the cloud emits more carbon than the atmosphere because they have to cool these hot storage. Anyway, a single data center can consume as much as 50,000 homes. And there are literally millions of data centers around the world, big and small, but some of them are 200 acres in size.
They look like nuclear power plants.
Yeah,
They're
yeah.
really-
So, and this is just so your
Yeah.
data can go somewhere instead of being on your little, this is 500 gigabytes. You could get one 10 times the size for, $50 or something. So, okay, more about the cloud. So storing 100 gigabytes of data in the cloud is about 2/10 of a ton of CO2 per year. It's about 4 car miles to store 100 photographs. So, it's so easy to take photographs now. If you've got little kids or whatever, it's snap, 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 snap. Apple, everybody just assumes you want that on the cloud. And it's kind of the default thing is to just send it straight to the cloud. So I was talking to a friend who said she had 100,000 photographs of her daughter. And so that's a lot of tons of CO2. So, again, using your personal hard drive uses, almost 1 million times less energy than putting it on the cloud. So another one, speaking of computers, is it's always so tempting to say, man, it'd be great to get a new computer. Mine's 4 years old. I'm sure, I could get something that's faster, et cetera. But there's a lot that goes into manufacturing just about everything. And this is an example I got from the MIT press about what goes into a single desktop computer. So stretch those things a couple years more, save a lot of carbon. Yes.
When you say desktop computer, do you mean one, like, are you talking about laptops as well as one with a big old computer box?
Yeah, I don't know. I would say since it said desktop instead of laptop, I would think it would be the box that's down at by your feet and a monitor or whatever. Yeah. Okay, everybody wants to reduce plastics, but there's a huge carbon connection with plastics. Obviously, they're made from fossil fuels. 100 million to 500 million tons of CO2 are emitted each year in manufacturing plastics. And then to get it to a personal scale, a 1-pint bottle of plastic bottle results in about 3 ounces of CO2 being emitted. So driving a car mile is about the same amount of CO2 as a plastic bottle of 5 plastic bottles. So, and I kind of tried to throw pictures like this in too, because I'm just talking about carbon. This is all we're talking about here. But all these things have these other impacts that are going on.
Wildlife.
This one kills me. The Pacific leatherback sea turtle population has plunged in the last 20 years, down to about 5% of what it was
They
25 years ago.
swallow plastic and they can't.
Yeah,
can't
they
digest
feed on
it.
jellyfish,
Yeah.
so they get tricked.
Yeah, people that have mylar balloons.
Yeah. Right, eat less meat. There's a big connection with animal agriculture. Raising livestock for human consumption generates nearly 15% of the total greenhouse gases emitted on the planet. Greater than all transportation emissions combined. This last one, it says it also uses nearly 70% of agricultural land, but I don't trust that figure because a lot of the rangeland wouldn't be suitable for growing other crops. They're just out there grazing on grass, but still it takes up a lot of land. And cow burps are loaded with methane. It's a huge source of methane. I didn't compare it to anything, but it's a big source. And I actually have a friend who was working on putting red algae, seaweed, into the diets of cows because it reduced the amount of methane that came out in their burps. And that was a very interesting set of experiments. Yeah, I don't know if this is too gross, but what they actually have cows back at, I don't know, the University of Nebraska or something where they've surgically implanted these doors, and they're clear plastic doors, so you can see into the stomach of the cow, and they can just open it up and take out a sample and close it back up, and they feed it different stuff. Anyway, so there's a whole. It's like if you're into agricultural, biology or whatever, there's lots of cool things you can do. Okay, so also, again, getting away from just the appliances around our house and stuff, policy matters. And I want to talk about policy. I don't want to talk about politics, but since individual people are involved in making policy, it's kind of unavoidable. I want to start with the 4th National Climate Assessment. About every 4 years, some of the best scientists in the United States pour over mountains of carefully documented data from an amazing array of instrumentation. It's really an incredible analysis that we are very lucky to have. And you look at that stuff and you say, my gosh, mankind has advanced so far to be able to do this kind of work. But so they produce a report like this every 4 years or so. And this one in 2018 said, with continued growth of emissions at historic rates, annual losses in some economic sectors, which means there's probably more if you consider all the economic sectors, projected to reach hundreds of billions of dollars by the end of the century. So this is a pretty big impact based on a whole lot of very good information analyzed by a lot of very smart people. And so every year they present this to the President of the United States, which they did in November of 2018. And the President took a look at it and he said, I don't believe it. Now, he didn't say, my science advisors have looked at this and we don't think this data source is good, or we think this analysis was done poorly. He didn't say, I don't agree with it. He said, I don't believe it. And this is not like believing in reincarnation of the tooth fairy. This is something very different. This is an analysis. It's something that you look at and you take apart. But the I don't believe it plays incredibly well politically. And I actually have an addendum, if we have time at the end of this, to kind of get into the psychology of why this works. I don't think this is I don't think this is strategically thought through as a statement, but it gives an idea of what the previous president thought of a lot of very good scientific work. And so what was the driving idea behind climate change type policy in the last administration? And this is a common photograph. And I'm not trying to be funny here. It's just, this is also, again, kind of an ancillary impact. This is top removal coal mining in Appalachia. It's hugely destructive. And but I just wanted to highlight that coal produces more CO2 than any other source of use for electricity generation, even though it's only about a quarter of the electricity produced, and maybe a fifth, I guess. And then, people talk about jobs. Whole Foods employs nearly 3 times as many people as the entire coal industry in the United States. Whole Foods, 3 times.
What?
It's actually like 2.5 times. The coal industry in the United States does not employ a lot of people. So why would you have coal drive your climate policy? I'm not sure, but that is one way to approach policy. More recently, with the Inflation Reduction Act, more money has gone into promoting a defense against climate change than ever was thought of before. It's really pretty amazing. Billions of dollars for clean energy, electric vehicles, adaptation projects. The projects on the map I showed around Monterey Bay, we're hoping to get those funded through the Inflation Reduction Act. And then the administration set a national goal to reduce emissions by 50% from the 2005 levels, and the EPA has changed the regulations to try and limit very potent greenhouse gases like hydrofluorocarbons and methane. So these are just a few of the things that are going on, but the point here is that there's a real distinction between the way different administrations, different policymakers address climate change, and it's something we need to be thinking about. And just on the basis of climate change, I know there's a lot of other things that people are thinking about in this election. The stakes in this year's national elections couldn't be higher. And I say national elections, and I want to make a point that we have a lot of political energy in Santa Cruz County. And a lot of it is directed towards local initiatives, which is great. But save some political capital and some money to donate to national causes, because there are some national issues that affect us highly. Okay, so another thing, what can we do with climate change? This stuff can be downright depressing. I'm sorry, go ahead.
So like smaller things or more, I guess, overarching policy, like national policy, or do you think will have a bigger impact?
Well, I think, nationally and globally, it's a national and global issue. If Santa Cruz County were to cut its emissions way down, that would be great. But unless, a whole lot of other people cut their emissions down. But locally, there's a lot of adaptation we can do. This 3CE sourcing of clean energy is great. It really takes both. Back and then. Not too.
Because electric vehicles oftentimes take the power from fossil fuel plants. I feel like we're starting to branch into the train on it, if that makes sense.
Absolutely.
Our policies reflect that, start at the base and then work our way up more towards the individual people and like only work our way up with them at the further stages in terms of our initiatives.
Yeah, I mean, I think you work where you can. And one of the things I really like about Central Coast Community Energy is that if we all have electric cars and are charging them off the grid, and the grid is getting energy from coal or natural or petroleum fired plants, then we're not doing much, which I think was your point. And so if you have solar panels on your rooftop and you're filling up your car off your solar panels, that's pretty good. Solar panels take, they get manufactured. It takes some carbon and plastic and everything to make solar panels too. So, ideally, I guess, use less, but that's a really good question. But I think you have to approach both and get what you can when you can from those different scales.
What about nuclear power?
Hang on a second. Do you have a question there? I think that's an excellent point. And it reminds me of around the year 2000 or so, there was an energy crunch in California because Enron and a number of the state government tried to diversify the power industry and create a lot of independent producers and distributors of energy to challenge kind of PG&E and the big producers. And so they opened up a market, and some big players came in and manipulated that market by buying up a lot of suppliers and buying up a lot of sources. And then they engineered a power shortage by putting their power plants on maintenance or doing this and that. And this was the Enron story where I can't remember his name, but anyway, Gray Davis was the governor at the time. And I thought he did the exact wrong thing. And this is kind of to your point. He came back and said, we're going to fix this with taxpayer money. And what he should have said is, we're going to fix this by putting the heat on the ratepayers. So that everybody, if I had been him at the time, I would have come out and I said, everybody cut your electricity use by 10% and we will drive these companies into bankruptcy. But instead, he tried to do a supply side thing and just build power plants and do all this stuff. And he eventually got recalled and was no longer governor. But anyway, yeah, that might have been a tangent. Did someone else have a question? What-
When you work on the, I mean, both are incredibly important, when you work on a national level, the amount of leverage you have increases a lot. And like, you're talking about getting that funding for our local projects from the national, from the Inflation Reduction Act. And it's really hard for small local communities to fund things like that.
Absolutely.
They're not getting, sort of the help from the bigger pool.
Yeah.
I think both sides are incredibly important.
Yeah, I agree. One good thing about local too is it's kind of an incubator for new ideas and new approaches. But you're right, there's a lot more leverage at the national level for sure. So we're in a tough spot. There's just no denying that we're in a tough spot, and it can be downright depressing if you think about it. It's important. I put the picture down here of put your own oxygen mask on first before you give it to your child. Take care of yourself. We need all of us. So there's a lot of things you can do. Being active is huge. Feeling like you've done something like switching to Central Coast Community Energy or changing out your gas water heater for an electric water heater or something, doing things is huge for generating enthusiasm and positive vibes. Exercise, if I'm ever feeling cranky, I get on my bike, about 15 minutes later, I feel great. But also just pay attention to your mind, because you can get feeling certain ways and you go, why am I feeling so angry? Or why am I feeling so bad? And if you just take a minute to think about it and dig down and figure out what's causing it, and then kind of work through that. Sometimes just get out, take a short walk. All kinds of good ideas will come up for how to deal with this stuff, because really it can be overwhelming. We are really in a tough spot. Human nature is not on our side here. And I've got a few slides, which I don't know whether we'll have time to get into about that. But I put a couple books because this is the Friends of the Library. These both come from a Buddhist perspective, but there's obviously all kinds of positive ways to think about the world in various other approaches. But think about it. Don't take your mind for granted. Don't take the way you think and feel for granted. Keep an eye on it, because it's going to be tough. But I think we can do this. Let's see. So with that in mind, I went online and just looked at Aptos library or not Aptos, excuse me, Selva Beach. And these are some of the titles that came up in the first 10 books on climate change out of hundreds. But it's a neat mix. Like one is, your mind, body, spirit. One is, extreme storms. One apparently is fairly humorous. It's called A Hot Mess. I think the one at the bottom is probably for younger readers about rainforests. I mean, there's just any way you want to approach this, we need a whole lot of different perspectives on this. So there's tons here at the library to learn more, and then websites. Is Laura here? Oh, you're Laura. Okay, shoot. Okay, great. Nice to meet you. I just wanted to get a couple of organizations and websites that I feel present really good, clean information that's not biased and it's very useful. The Union of Concerned Scientists operates on a national, international level. The Citizens Climate Lobby, which Laura represents, and I think, do you have some materials for us there? Okay. Okay.
I'm also.
Oh, good. Okay. Because I've been really impressed with the Citizens Climate Lobby. They've come up with some very practical, national level. I mean, I don't know, 10 years ago, there was a carbon fee and dividend initiative that I just thought was fantastic.
It hasn't gone away.
Okay, good. Okay. Okay. So then also at the California level, I bring up the Climate Center because I've been impressed with a number of things that they've been doing. And then at the Santa Cruz County level, there are lots of organizations, but I'll put Ecology Action up here. Ecology Action 30 years ago was kind of running the recycling plant. Now they've got 60 really sharp staff members doing all kinds of things. A lot of it's on climate. And then the county is still working on, it's kind of an evolving climate action and adaptation plan that's really good. There's a lot of good resources there too. So I'll end it there. I'll take some questions. If anybody wants to know what I know about psychology, we could do a little bit more, but I'll leave it there.
Let me,
Oh, thanks, Sandy.
let me turn on first. Okay. And remember, this is for our online audience, so they can hear your question. It's not going to magnify your voice for this crowd, so if you can still keep your volume up, and so everybody in-house can hear too.
You didn't mention much about nuclear for a power source, and I was against it when it first, because it's dirty, but I think that the modern fusion might be an answer if it could be made done. Is that what you're taking on nuclear power? Because it's
yeah, I haven't kept up with fusion lately, but the word up until, for 40 years, up until I last checked a decade ago or so, was that fusion, atomic energy from fusion is perfectly safe because it doesn't work. So fusion, of course, was what drove the Lotus car in Back to the Future, where he just throw a banana peel in the back. And I mean, it's an amazing thing. It's what the sun runs on. But the trick for years in fusion is that the reaction happens at, I don't know, 6 trillion degrees or something. And it's finding a bottle, a container that will hold that reaction. Has been a big deal. And
but besides the science of it, does it need the amount of cooling water that fission does? Because fission is always situated where it's changing the temperature of the water.
Yeah, I don't know.
To cool the reaction.
I don't know. And fission, the byproducts from fission are poisonously radioactive for 10,000 years, and so it's a, that's a devil's bargain between climate change and fission. So, I'll have to let you kind of come down where you do on that. I know that the Diablo Canyon nuclear power plant was set to be retired about a year ago, and Newsom is keeping it open for another 5 years because it's there and it's working and it's carbon-free energy. It's a crazy thing. My kids are in favor of nuclear energy over climate change to a point.
Yeah.
So just, but anyway, it's a tough one. In the back.
Excuse me. As much as I'm worried about I think that fusion could be a decent technology, I'm also I think in terms of we can just diversify and improve the stuff that we already have. I know hydropower has issues, solar has issues, but in terms of solar especially, we're already getting that is energy from fusion so does just everything else on this planet. It's all energy from the sun and from fusion. So in the context of that, I think that just improving our current systems to be more reliable, like solar has such a long way to go. It can be improved so much. I think we have so much good sources already that just need a little bit more work in to the point where they can really be reliable and decent.
Rather than investing in nuclear.
Yes.
Yeah.
I
Yeah,
mean, I do think it could be a plausible technology, but I think we also have so much as well that we can go into.
Yeah, I mean, as I mentioned before, it really wouldn't take that much for everybody to really decrease the amount of CO2. The microphone?
Just changing the subject. I I'm really interested in biochar ever since I learned about it some years ago. And I'm right now all over the county. Trees are coming down all over, huge trees being felled, and they are being chipped. And that carbon will go back in the environment within 2 to 3 years. And so I'm very interested in whether there are any local or California projects to actively make biochar on a large scale. I think it sounds great, and I'm not sure about its energy use. I know that it requires heating the wood in a low oxygen environment. So I don't know about the finances, but is there anything that you could tell us about projects?
It's not on a large scale, but it's on a pretty good sized scale at the Elkhorn Slough Reserve, the Elkhorn Slough Foundation. They've been doing a lot of eucalyptus removal and doing biochar with it. And as I mentioned before, I've been involved in some projects for water quality where you create these ponds full of biochar, and you'll take runoff from some polluted source, run it through that. It comes out pretty darn clean on the other side. It's like carbon filtering surface waters, and you could probably do it with groundwater as well. But I would say either I think maybe Monique Fountain at the Elkhorn Slough Foundation might be a good source, and she could at least point me to somewhere. The Prescribed Burn Association uses a lot of biochar in their projects, especially when they're not doing a prescribed burn, but they're just doing fuel reduction by chopping down trees and trying to get them out of the way. Yeah, it's an interesting thing because I don't know what you do with all that charcoal. It's a lot. But, and I just wanted to say one more thing about chipping the trees. They're probably taking them to that cogeneration plant out there on Highway 5 near Modesto, and they burn it for electricity, and the carbon goes back up in the atmosphere. But at least it's a balance where the carbon was pulled out of the atmosphere by the trees, and then it's going back into the atmosphere where it's burning. If we were on that kind of a rotation where all we burned was plant material, it would at least be neutral. It's being pulled out of the carbons out of the atmosphere first, and then put back in when the stuff burned, rather than pulling fossil fuels out of the ground, which wouldn't, are just added. It's just an addition.
Well, they're neutral before they're pulled out.
Yeah,
Or,
right.
I mean,
Yeah, if you leave them in the ground, they're fine.
Yeah.
I was just going to say that Alcorn Slough was what we have been doing with biochar is we've been giving it to the gardens, the fields that are around us, the strawberry fields and other fields that are around, and feeding water into the slough area. And it does help clean up, take out the minerals from the soil that was used in the production of, pesticides and all the other stuff that's been put in. So that's what they've generally been doing.
Yeah, that's excellent, because that is a place that can accept a lot of material. Other ag fields.
In the fields instead of using fertilizer.
Right. And it's soils are a great place to sequester carbon also. Healthy soils with worms and fungi and all that kind of stuff will soak up a lot of carbon. Another question?
Do you think it's possible to or more so bioengineer like a solution that would be able to take in terms of like plants being able to take in like passively take in much more carbon than currently? Because I mean, theoretically, in terms of like gene editing technology and whatnot, it's come a long way and likely has a long more way to go to the point where we could create systems where we don't necessarily have to actively interact with the environment, but instead just let the plants do their thing, reproduce, and kind of passively take carbon out of the environment to a scale, because right now we don't have obviously that same kind of like carbon capture. They don't quite do enough, but I mean, if we were able to bioengineer solutions that could and would still fit into their existing ecosystems, couldn't that be a valid solution?
I think it certainly could be, and it's something I know very little about. I know that NASA was working on phytoplankton in big bags to harvest basically the oils from the plants to use as a fuel. But so you could there's probably some sort of organism that could run the other way. I would think, soil bacteria, soil fungi might be a really good place to look for that. When you get into bioengineering organisms to be more efficient at that, then you obviously kind of have to keep an eye out for side effects that you might not anticipate, but Frankenstein type things.
Hey, John, do you take any solace from the idea of peak oil? The fact that they're predicting that oil consumption is going to peak in this foreseeable future?
Yeah, I'll take that. Definitely. I mean, I should have followed it. Brent probably knows this because he reads the paper more than I do, but at the climate summit where was it? Qatar? There was some commitment made by the oil producing nations to do something, and I don't know, do you have a sense for that?
No,
Yeah, okay.
But also economically, they're estimating a peak where it's going to be less economically
Yeah,
viable to use.
competitive.
Yeah, it's going to
Yeah.
be your sources or other sources will be more economically viable.
Yeah, that's what's happened to coal. Coal is being reduced because it's not competitive price wise with other sources. And so, yeah. And so that, the more we can do to outcompete those sources, drive the market for sure. Okay, thank you all. Okay. Sandy, do you have anything else that you have?
Let's just say.
Just a quick look on the website that does the carbon capture in Iceland. Just because there's a lot of questions about it, I was curious myself. Apparently they mix the carbon with water and then they do bind it to rocks.
Yeah.
So they bind it to basalt underneath the ground, and that's what they were.
Yeah.
Apparently that's what they're doing.
Yeah.
Thanks, Kyle.
Yeah.
Thank you, Sandy.
Thank you.
Oh, thanks. Thanks for